This is the video tutorial for pages 9 and 10 in your Unit 4 homework packet. So today what we're doing is naming with polyatomic compounds. This is going to be the same as we've been doing the last 2 days of homework. You name the cation, the metal, and if you need to, you use a Roman numeral just like we did on the last assignment, and then you name the anion. So it had been that our anions were nonmetals, so fluorine became fluoride, or chlorine became chloride. On today's homework, you're noticing that we've got stuff in parentheses here, which are polyatomic ions. And so if the anion is a polyatomic ion, like this one, C2H3O2, then you just copy it exactly from this list. You don't modify anything on this list. The only exception would be our 2 errors, our 2 typos on here. This NO big 3, this should be a subscript 3, like this one. Nitrate is NO little 3, it makes a -1 charge. And nitrite is NO little 2, and that makes a -1 anion as well. Okay. There is a mistake. Number 5, the subscripts were flipped. So just go ahead and copy down germanium 2 phosphate. Otherwise, you're going to think it's germanium 9, and there's just no way. So go ahead and write down germanium 2 phosphate for number 5. And we're going to start out with number 8. We're going to do number 8 and 9 together. Okay. So our first step up here is to name the cation. For us, the cation is calcium. So I'm going to find calcium and decide if it needs a Roman numeral. Because calcium's in family 2, it always makes a +2 charge. So I don't have to call it calcium 2. I just call it calcium. So no Roman numeral needed. Calcium. And then parentheses tells me to look at my polyatomic list. C2H3O2, that's this first one, and that's acetate. So I'm going to go ahead and just call it calcium acetate. I don't modify anything on this list, this polyatomic list. I just leave it as acetate. Okay, number 9. Ni is my cation, so I'm going to name it nickel right here. But I also need to notice that it's going to require a Roman numeral. Remember, the 1 and 1b that always makes a +1, the 2 and 2b that always make a +2, the 3 and 3b that always make a 3 and 3a that always make a +3. These ones don't need Roman numerals, but nickel is not in that block. So it's going to be nickel, blank, and I'm going to leave room for my Roman numeral later. And then I need to find my anion, my polyatomic, HClO right here. Hydrogen, chlorine, and oxygen is hypochlorite. So I'm going to go ahead and copy that exactly. Hypo, C-H-L-O-R-I-T-E, hypochlorite. All right. Now, in order to find my Roman numeral, I need the charges, because the Roman numeral is the charge that nickel is making. I don't know what charge nickel is making, but I can use the subscripts to uncrisscross and turn them back into charges. Okay, so I'm going to take the 2 that's outside of the parentheses, because that's the subscript, and I'm going to pull it up here, and I'm going to take the subscript that's after nickel, which is nothing, which means it's an invisible 1. I'm going to pull it back up here for hypochlorite. And then it's always cation, anion, so positive first, negative second. Now I'm not allowed to just use that. I have to check my anion. So I'm going to come over here to hypochlorite and see that sure enough it does make a -1 charge, which means my charges are correct. So this nickel is making a +2. So when I name it, I call it nickel, making a 2 charge, nickel 2, hypochlorite. Okay, we can keep moving on to 10. 10, Zn3PO32. Zn is zinc, and zinc is in that block. It's one of the 2 and 2b that always makes a +2. So I don't have to call it zinc 2, I just call it zinc, no Roman numeral needed. Zinc, and then PO3 is phosphite down here. PO3, phosphite. So I just call it zinc phosphite. Alright, name the metal, the cation, give it a Roman numeral if it needs, and then just copy the polyatomic exactly. Down here on the bottom half of this page, it's a lot more like your test. It's mixed up. So we've got some of them that need Roman numerals, some of them don't, some of them with polyatomic, some of them without. So if we're looking at something like 19, K, potassium, is in family 1, so it always makes a +1. So I just call it potassium. And since it always makes the same charge, I don't need to give it a Roman numeral. O is oxygen, so I change the ending to ide. Ox-ide. Potassium oxide. But then we come down here to a problem like 21. I've got aluminum and phosphate. And I would find aluminum on my reference chart. I've got a sticky note there. Sorry, y'all. Okay. Aluminum right here is one of the 3 in 3A that always makes A +3. So I'm not going to call it aluminum 3. I just call it aluminum. Aluminum. And then PO4 down here on my list. PO4, there it is phosphate. So I'm going to go ahead and copy that exactly. Phosphate. Okay. You officially know all 3 kinds of naming. Wonderful. All right, go ahead and turn over to page 10 with me. Page 10 is then writing formulas for polyatomic ions. Okay, so write the symbols. That's what I'm going to circle. I always tell my students it's symbols, charge, crisscross, reduce, and erase. Those are the 4 steps. Symbols, charge, crisscross, reduce, and erase. The only thing that's going to be a hair different is that we keep polyatomics together in parentheses. Okay, we're always going to use parentheses around them. So let's start with 11, 12, and 13. Potassium phosphate. Potassium symbol is K. Phosphate, I would look up here on the periodic table on my reference chart. Phosphate is parenthesis, P-O little 4 parenthesis. So I'm going to copy it exactly. Parentheses, P-O 4 parentheses. So it looks just like my periodic table. So that's step 1. Symbols. Step 2 is charge. Potassium's an alkali metal. It's family 1. It always makes a +1. PO4 is making a -3 charge because they told me on the reference chart. -3. Next step is to make a net overall neutral or just crisscross. So my 3 is going to come here before the parentheses, and my 1 is going to come here after the parentheses. And then I'm going to reduce and erase. And for my class, I always have my students rewrite. So it's K3 parentheses PO4 parentheses, and then an invisible 1. Do not write the 1. Potassium phosphate. Be very careful. There's only 1 letter difference. Phosphate or phosphite. A or I. But it's different. So I'm going to come here and find phosphite is PO3. PO3. It still makes a -3 charge on my reference chart. So when I crisscross, it's K3 PO3. Just like that. Potassium phosphate, potassium phosphite. Potassium phosphide, IDE, would just be K and P bonded together. All right, number 13, chromium nitrite. Because it ends with an ITE, I know it's going to be here on my list. Okay. So chromium is Cr. Nitrite is one of those ones you have to be careful and make sure you use the little 2. But it's parentheses NO little 2. NO2. Okay. Then I write the charges. The charge of this chromium, they told me in parentheses. This chromium is making a +3 charge. It doesn't always, but this time it is. And nitrite on my list, it tells me uses a -1 charge when it bonds. So I'm going to put a 1 here, and I'm going to move the 3 here after the parentheses. You're not allowed to change anything inside the parentheses. So this would be chromium, invisible 1, parentheses, NO2, parentheses, 3. Okay. It means I need 3 nitrites in order to bond with 1 chromium. Each nitrite is going to take 1 electron. Chromium wants to give away a total of 3. So there we go. If you come through and look at this, this ends in 8, 8, ide, 8, ide, 8, 8. Okay. All of your polyatomics end in something other than ide, except for cyanide and hydroxide. Okay, cyanide, Cn, and then hydroxide, OH. Otherwise, your polyatomics, you can tell it's a polyatomic, or tell that it's binary, because it ends in "ite" or "ate" or something else. Okay. Remember, almost right is wrong in chemistry. Good job, y'all. If you need some more help, please don't hesitate to come in for after-school tutorials.